Hello, everyone. So in this video, we are going to be talking about scientific method. So guys, we will discuss what it means and how do we, basically follow the scientific method. So the idea is that whenever, you're trying to learn something or understand something about the world, you basically emphasize on making the observation, and then you want to understand and that observation and try to explain it, and then that explanation needs to be supported by gathering some data or running some experiments, right? So think of scientific method as a logical approach, a step-by-step logical approach to get to the conclusion where you do your best to make sure that you're reaching uh, the the best correct explanation, right? Best correct conclusion. So you can so scientific method, it consists of you can use the word steps. uh you can start with, let's say, an observation, and we'll discuss later that this is a cyclic process. So there's no starting point whenever you're trying to answer a question. So uh the observation, is basically just getting the sense of the external object. So you measured something, or you saw something, you heard something, you smelled something, and for example, you see that you smell decomposing garbage, or you see a pencil drop to the floor, or you see the sky is blue, or you see cloud formation, you see the color of leaves is green. And based off these observations, then you start asking questions, right? And those questions could be, why did that pencil drop? Or why is that garbage smelling? Why is the sky blue? How does the cloud form? Why are the leaves green, and stuff like that, right? So you ask all these questions. Now, uh, the after you ask the question, then you think of possible explanations, right? So those possible explanations are what are called hypotheses. Okay, so hypothesis is you trying to give a tentative explanation, or trying to give a tentative answer to your question. Okay, it may or may not be true. It's just that it's just the possible explanation to begin with. Okay, so now once you make the hypothesis, you want to know if this hypothesis is true or not, right? Now, how do you do it is by running some experiments. So you now want to test the hypothesis. So you test the hypothesis, uh, with the help of experiments. Okay, so you collect some data, you change some variables, you run the experiment, and then figure out if your hypothesis that you gave was true or not. Okay, so when you now do the experiment, the next step will be to analyze the data, right? So you do the experiment, and then you analyze the data. So what is the data actually telling you? Is it telling you, is it directing that the hypothesis is true or not? Okay, so once you've analyzed the data, once you've analyzed your results, you basically try to give what do you call a conclusion. Okay, so that conclusion could again uh, 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 would be of course an explanation, but like hypothesis was the tentative explanation, conclusion is more like gonna say that that hypothesis, that explanation that you gave, whether that was true or not. So basically, conclusion is telling you whether your hypothesis is true or false. Okay, so conclusion tells you whether your hypothesis is true or false. Okay. Um, so now if your hypothesis is true, that's great. And if you want, you can, do some more experiments to prove it more, or, you can take it to your colleagues to review it, and, your colleagues and peer to review it, and, then you can publish that data. But then what if it was false? If your conclusion says that your hypothesis is false, then you go back, and revise your hypothesis, right? So now when you revise that hypothesis based on the results you got, then you're gonna, of course, then test that revised hypothesis by running the experiments. And then, so this is a cyclic process, right? So you keep running experiments until, you get to that um, um, true hypothesis that you're expecting, or not. You were expecting or not, that you don't know. Um, so then where does the theory comes in? The word theory, guys, think of theory as the answer, as the explanation of what you're observing. So once the hypothesis has been tested several times and have been tested to be true, you start calling it a theory, because think of theory as as a well-established hypothesis, which has been supported with considerable evidence, and is very well supported. Okay, so for example, for theories, you might have heard of Big Bang theory, theory of relativity, which was given by Einstein, or the theory of evolution given by Darwin. So all those theories, they have been very well accepted, and have been proven multiple times. Okay, all right. So now, if we talk about the scientific law, let's see, what does that mean? Okay, so scientific law. So don't think that theories are what becomes law. Theory is a different thing. Law is a different thing. Uh, think of scientific law as, think of it as a statement which basically summarizes, it summarizes the relationship between the variables. Okay, you will see scientific law usually to be written as formulas. So, for example, law of conservation of mass, which tells you that the mass of the reactant should always be equal to the mass of the product in a closed system, or law of gravity is an example of law. So it is, again, just a statement. It is not an explanation. Theory is a detailed explanation. Law will just give you the relationship between the variables. So for example, you will see formula like PV equals nRT, which is called ideal gas law. Guys, this is a law, and you see all these variable. P stands for pressure, V for volume, N for moles, T for temperature. We haven't learned this yet, but don't worry. So take my word right now for this, that these are just different variables, and the relationship between them is explained with the help of the law. Again, this is not an explanation. This is not explaining you anything, but just gives you relationship between the variables. Like if one changes, what happens to the other one. So again, remember that theory does not become law. They're two different things. Okay. Now, when it comes to so let's take some more examples to understand each one of the things we just discussed. Okay, so let's take an example. You made, for example, an observation. Okay, so you made an observation that the pencil dropped on the floor. Okay, so the pencil dropped on the ground or on the floor. Okay, so so this is, again, this so this is the observation. You can take this as a fact. You can say a fact that whenever you're going to drop a pencil, so whenever you drop a pencil, it falls to the ground, right? So this is, think of fact as something which is such a common observation that we know for a matter of fact that this will always happen, right? So whenever you're going to drop a pencil, it should fall to the ground, right? But again, remember in scientific method or in scientific community, in science, basically, you never say anything for 100%. Okay, so there may be, you know, an infinitely small chances that if you're going to drop a pencil, it might not actually fall on the ground. So it leaves that space of error every time. Okay, so now the next will be, you know, you ask yourself a question that why does the pencil actually drop or falls to the floor? Why does it not actually go in the opposite direction, right? So you ask yourself that question. So on that question, then you will make a hypothesis. What will be hypothesis? Your hypothesis will be that the pencil drops because there's some kind of force which is pulling it down, right? So there's some kind of force which pulls the pencil down, right? So just a possible explanation. Okay. All right. Now what you will do, of course, is you will run some experiments. You're gonna, first of all, see if this is true for everything. You will see if it depends on, you know, the mass of the object that you're dropping. If you go from a lighter weight object to a heavier weight object, does this still stay the same? Do you still make the same observation? So you conduct all those experiments. And then, you know, eventually, when experiments will be done on this, maybe at the end you will be able to even explain, you know, based off all the observations that will be made during the experiment, then maybe at the end you will be able to give a theory, and that theory, you know, could be that anything that, you know, has mass will, you know, attract something else which has mass, right? Or later on, since we after, you know, after Einstein, who gave us the theory of relativity, what we learned was, you see, he changed the law of, I mean, the theory of gravitation that was given by Newton. So he was able to, so Einstein was able to explain what actually gravitational force is. So you to see, he later explained that the mass, you know, or energy, it can cause the time to curve, the space time to curve, and and because of this curvature of the space time, the force of gravity arises. So this is the theory. This is the explanation of what is gravitational force. What is actually, you know, pulling a lighter object towards the heavier object towards itself. Okay, so again, you don't have to understand this for right now, but just know, I mean, you don't have to understand the gravitational concept for right now, but at least understand that how that what theory is, that it is the explanation, you know, of any observation that you made. Okay, so that will be again the explanation. Okay, so the explanation for that is again that is the curvature of space-time, okay, which give rise to the force of gravity. Okay, and who is able to curve the space-time? Any object that has mass is able to curve the space-time around it. Okay. All right, so that is the theory, right? Now, what will be the law? So that's the next thing. That's the last thing we're going to learn here. The law is the gravitational law, right? So gravitational law basically is the statement again, which is going to remember, which is going to summarize the relationship between the variables. So the law of gravity just explains, it says that any matter that has mass, of course, right? It is going to attract. It is going to attract the other matter, okay? And it will be proportional. So it will attract, that force of attraction will be proportional. So that force will be proportional to the mass of the two objects, and it will be inversely proportional to the square of the distance between them. Okay, so you see this mathematical relationship. Just this statement is what the law of gravitation is. Okay, it is not explaining anything like what is actually causing the gravity to first of all exist, and then how does it, make two masses interact with each other. It just says, okay, if one mass is heavier, if the mass is heavier, then the force will be more. If the distance is more, then the forces are going to be less. Just that relationship between the variables is explained by the law. Okay, so I hope that is making sense. Okay, so that is it for this video. We'll see you guys in the next one.